So we spent over there, and then Connor was there, so I was like, oh, it's faster.
I haven't seen it.
Are you good at your
Okay,
job?
Trevor, why does Alicia work at Harvard? She doesn't get a job today.
I know.
Seriously, that makes no sense. Yeah.
Yeah,
There's
probably.
plenty of jobs today.
Yeah, that's what is it? Does Connor work? Yes. Got a red work today? What is this? Oh, to be
She's gonna try to show her voice. We're gonna be around.
He's like, he graduated a year ago.
Stop, sure.
He's like 22. Okay, okay, stuff I do.
Yeah, I mean, that
Still waiting. Oh, to make sure close the bed. Yeah, that's him.
Oh, yeah, yeah. Yeah, I've definitely seen that. I see that. Yeah, I figured it out. In the party, that's where I don't see it.
I was looking at all these.
I don't like answering these people.
It's pretty lit. She lives in Bridge. She's a nice lady. Jared, Christy. This, I don't think it's work very much. We need to calm down this morning so I can feel like school.
I'm like,
Where are you going? Yeah, I think 2. We have 4. We get out at 37.
yeah, 37.
Guys, Trump won. Oh, no, I fell asleep while I was watching it, and I woke at 2, and Trump was giving a speech. And I was like, oh crap, I missed it. So then I posted the thing on the story.
I don't know why. That's not Oh, I got a lot.
I was so sad. Ask me a question. When I fell asleep, I think, how is it at 2:15? No. How much did you
I get paid more by 8 hours. Well, not, I guess it's I get 7 hours, but I got paid 7:55. Or no, at first I got paid 7:35, so now I get paid 7:55. I get
What did your brother say?
well, I guess I get
don't know what
less, but
Yeah. I logged on this morning.
I still get paid like
I remember better questions last year. I actually
Facebook. I saw this. It was like
Okay, make sure what is due today. Worksheet if you haven't got it in. I don't know if I got it from everybody. I got it to you, Joe.
Yeah, it must be 37.
Madison Taft, please come to the office. Madison Taft.
Morning.
Morning.
Did the person you voted for yesterday win?
No comment. You can take that however you want.
I voted yesterday.
Or what does invalid stuff? Yo, you ready? I heard you and Jack on the mannequin challenge.
What?
I heard you and Jack on the mannequin idea.
Madison Taft.
I'm scared because I'm a woman.
It would be bad if you shut up.
And then that same person asked, isn't Trump the one that wants to do not talk about
Trump won. Oh man. Except for
I tweeted it.
Where's Stanford all day?
I know, it was only
I'm
like
scared because I'm a woman. And then 2 minutes later, isn't Trump the one?
Because I put the wrong price
Oh,
tag
I
on it. Maya.
I was going to say, it sounds like Maya. I was like, here. You ready?
what's the yours? I can't think of it because
Hey, let's take a seat.
He's doing an interview with
Take a seat.
He is real nice. He's actually really laid back.
All right. Hey. All right. Quick question. Quinn here is not finished test for me. The test on chapter 1. Yeah. My goal is to hand it back Friday, so you can actually take a look at the scores, and then you got a week if you want to retake. Yeah, that's fine. You can do it. Yeah.
I lost all my numbers. I have a memorized. I lost memorized.
Hey, so if we can, let's try to wrap those up today if we can do that. All right.
right now.
I want to get those graded. All right. Okay, so first and foremost here, what we're going to be talking about today is quadratics. I want to finish this up so that way tomorrow, when your sub is here, you kind of know how to do the homework on your own. You won't have to ask them too many questions because they're probably not going to know how to do any of that. So what we're doing today, we're doing a quick review of the measuring numbers, just to give you kind of an example of each type that you should know. we'll do a quadratic equation problem, and then we'll talk about how that could be different and why we use these imaginary numbers. Because we kind of did yesterday. My goal today is to spend the most time today doing completing the square. Do 2 or 3 examples of that to make sure you know how to do it, especially with odds, even numbers. Know how to find the vertex, min and max, kind of a thing. Know where the tails go, the end behavior of the actual graph. And then what we're going to do is we'll try to do at least one example today where we reverse engineer a problem. Where you guys give me a coordinate for a vertex, give me a coordinate that's on the actual parabola, and we actually make our own equation for it. That type of thing. Okay. Questions, comments on what I want to do today? Okay. So let's walk through a couple examples here. I want to start with the imaginary numbers. I'm going to just put a couple on the board here, and we're going to kind of see how well we can do. Okay, the first couple. All right. So the first couple problems, just basically we add and subtract imaginary numbers together. Now in this particular problem, there's no radicals. They've already kind of simplified everything we need. But how do we add and subtract these? What do we need to do first? Okay, distribute the negative. Okay, so when you distribute the negative, this is what we have. We can get rid of the parentheses as we distribute. So negative 4i, negative 3. Okay, you're distributing the negative. The 6 isn't multiplied. It's literally 6 minus whatever that parenthesis is. In the back, what do I need to do back here? Are you doing it? Nothing. So it's literally the parentheses there is just confusing. The plus sign, you don't distribute the plus sign. You don't need the parentheses. Now we can combine like terms. Your answer should always be written in what they call complex form. Okay, so complex form means the whole number up front, the real number up front, the imaginary part in the back if you have one. Okay, so what do we get when we add or subtract these numbers together, the whole numbers? Yeah, 6 minus 3, which is 3, plus 9, which I heard was 12. That's good. And then what about the imaginary numbers? Plus 1i. If you just put I, that's totally fine. Okay, if you just write like this, it's the same as 1i. That's your answer. Make sense? I want it in complex form. Okay, let's do another one here. Next example, let's go with 7 plus a negative 3. And we're going to square this. So now we're moving on to multiplying. We add and subtract, and now we move on to multiplying. Okay, what does that power 2 mean? Yep, you have 2 parentheses multiplied together. So we have 7 plus negative root 3 times the 7 plus negative root 3. That's what it means. Yes. So now that we've written down what this actually means, you need to pull out the I on that problem first every single time you start that problem. You have radicals. So this, when I pull out the I, the negative sign will go to the outside and becomes an I. Because what I actually did was separate negative root 3. I actually separated the negative 1 and 3 like this. That's using the product rule. And then this turned out to be the I. That's why it turned out to be 3, or I root 3. Okay, and then I'll do the same to the back. So I'll pull out the negative sign and just put an I out front. And now we can start the problem. Does everyone understand that now? Okay. And then again, the goal in the end is to get my answer into what we call, complex form. So have a real number plus imaginary part. So we'll distribute. So that's 49, 7 times 7. 7 times the I root 3 is 7i root 3. Middle, 7i root 3 again. And then last, I times I is I squared. And then root 3 times root 3 is root 9, which most of you know what that the answer to that problem would be. So that's multiplying the back items together. Makes sense so far? Okay, then what we're going to do is we're going to try to simplify this. So the middle terms can actually combine together. So that makes what, 14i root 3? Because that's how you add. You just add the leading numbers out front. You don't actually add the radicals or anything like that. Back here, this is actually a negative 1, and the square root of 9 is 3, so I'm actually multiplying those together. So that's actually just a negative 3 back there. So what's 49 minus 3? Right, so your final answer here, if I want to write it in like proper, complex form, it'll be 46, that was the 49 minus 3, plus 14 root 3 I. That's, that's the real number, that's the imaginary part in the back, and you notice that I kind of separated that so you can kind of tell what's in front of the I. The I is not underneath the radical, it's not.
So,
Yes, that would be totally fine. As long as you have the real number in the back. I'm just separating the numbers from you. So yeah, here that percent work like this. 5, 4, 2, 3. That's not fine. Yeah, that's fine. You can do that. It's just in the book they might show the I in the back. Just so you know. Okay, questions on multiplying or this idea of adding and subtracting? Okay. Last example I want to show you here is if we were to do a division problem. So let's go negative 6I over 5 minus I. Okay, so let's say that this is my problem, and I want to simplify this problem. So it's a division. So, and we have a weird complex thing on the bottom, a complex number on the bottom. We have to multiply by the conjugate. You have to use the conjugate in this case. You can't just multiply by I. You have I's everywhere, and they won't go away. So when you multiply the top and bottom, you have to pick the conjugate of the bottom, which is 5 plus I. And then take the top, which is 5 plus I. Okay, once we have that, now I can distribute. So I'll distribute the negative 6I to both the parentheses, to both numbers in the parentheses, I should say. So that's going to be a negative 30I, because it's negative 6 times 5, and then the I goes behind it. And then I'm going to have the negative 6I times the I, which is negative 6I squared. So that is the top. So everyone see how I distributed the negative 6I through it? The bottom, you have to FOIL. First, average, last. So the bottom actually turns out to be 5 times 5 is 25. 5 times I is 5I. Negative I times 5 is negative 5I. And negative I times I is negative I squared. So yeah, and then this back here, that you're absolutely right. That's a negative 1, right? That's an I squared is a negative 1, and we have a negative in front, so that's just a plus 1. So it's a negative 1 with a negative sign in front of it. These cancel out, so no worries there. Those are gone. And so, and the top, this actually turned out to be negative 1 times a negative 6. So really, if I kind of rearrange the top a little bit, negative 6 times negative 1, that's 6. It's a positive 6. I'm going to move this negative 30I to the back. So I could at least put it in somewhat of a complex form. And then what's on the bottom? We have 26 down there. Okay, question.
On the top one, on the negative 6I squared, how come it's not negative 6 plus 1? So like it's I squared.
I squared is a negative 1, and you have to take that to whatever the number is. Because that's, are you talking about like
how come I squared doesn't make half of 1?
Oh, that's what we talked about yesterday, was that, the square root of a negative doesn't exist, right? So that's why we have the imaginary. So when they square an imaginary number, I know that seems weird, like it's not positive. The answer for when you square an imaginary number is also representing the impossible. The idea that you can get a negative 1 up, because how they show it is they show it like you square both of these, what would happen is you have I squared equals typically you get negative sign cancel, but since this is imaginary, this is representing the impossible, the imaginary part. It would be a negative. Does that make sense? Okay. Yeah, I agree. Squaring something should turn out to be positive, but the I squared represents the negative and not imaginary part. Okay, the last step here is I put the 26 in the both. So it's 6 over 26 minus 30 over 26, and I have the I's. Okay, questions, comments, concerns?
Simplify that?
Yes.
The 30 over 26.
These simplify so that, if I divide these both by 2, that's 3 over 13. Divide these both by 2, we get 15 over 13. You just simplify the fractions. The I just goes out back to
to do that?
Yeah, because you have to put it in complex. Real number separate from the imaginary part. It can't be one big fraction that's all together. Yeah. Not interchangeable. Yes. Okay, questions on what we talked about today? All right, let's move on. Okay, what we're going to go on to now is the quadratic formula, the quadratic equation stuff, where it's like the beginning of like graphing, right? So whatever equation we have, we can actually use the quadratic formula to help us solve that. So I'm just going to make up one here. So let's go 2x squared plus 4x plus 7. So that's a quadratic. Agreed? Equal to 0. Typically, like in quadratic, you could set this equal to y, now it's a quadratic function. It's the same idea, it's not a big deal. But for our purposes right now, I'm going to say equal to 0. Now, why would we want it to be equal to 0? I want the y numbers to be 0, so that when I actually do the quadratic formula to this thing, I can figure out where I'm going to hit the x-axis. Okay, that's what the quadratic formula gives you. So, in fact, I want to put it over here so I can graph this here in a minute. All right. So the quadratic formula, this is your A number, that's your B, that's your C. The A, B, and C are the leading numbers out front. It's not the variables, it's the numbers that are sitting there. I don't know why, some people always, they go a little bit overboard when they're trying to do the quadratic formula, they're trying to plug in variables, and it doesn't go right. So this is the formula that you got back from Algebra 2. Negative B plus or minus square root, B squared minus 4AC, over 2a, right? So, what I'm going to do is I'm going to take the A, B, and C number and plug it in here, and then we can solve this thing out. So, what we have here, negative 4 plus or minus square root 4 squared minus 4 times A times C, and this is all over 2 times A, which is A is 2. Okay, so does everyone see where we got the B, A, and the C's, and I'm plugging them into that formula where the A, B, and C are sitting? And if they're negative, the negative sign goes with it when you plug it in, that sort of thing. So, no, that was a negative 7, minus 7, you plug negative 7 in here. Okay, now at this point, if we actually simplify this out, what we'll look at is basically this thing is going to turn out to be x equals negative 4 plus or minus is all over 4, and then the square root is 16 minus 28 times 2, is that 56? When you actually subtract that, I get a negative 40, which is a really, really weird number. And that's why the graph doesn't look right, because the idea is that we have an imaginary number. Negative 4 plus or minus square root negative 40 all over 4. And this, if I want to simplify like into radical, like or into complex form, right? I can take the negative out, so that would be the I, and then I can break down 40. 40 has a 4 in it, 4 and 10. And so I put the square root of 4, that would be 2, right? So that would be plus or minus 2I root 10, right? Because the square root of 4 is 2, comes to the outside and 10 stays in there. Have it over 4, and the final answer, what I need to do is put 4 under each item. And that would be, that would be separating it and putting it into complex form. So negative 4 over 4, which simplifies, plus or minus 2I over 10 over 4. Now, what would that actually simplify out into? Negative 1 plus minus when I simplify it, just the 2 and 4 simplify, so it's I root 10 over 2. Now, if you want to put the I out back, put it like root 10 over 2I, that's fine. But I simplified the 2 and the 4, the reason why they're not in radicals. That's why I can simplify those. Notice the 10 was not touched. It's in a radical, you really can't simplify it. Okay, do we agree it's imaginary? What that means What this literally means is that I'm not hitting the x-axis. That's the whole point of doing this. We're getting imaginary numbers. I'm not hitting the x-axis, so it's nearly impossible to graph this thing, because all I really can tell you is where the y-intercept is. Like one dot. That's what I can tell you right now. So in fact, let me pull up a graph here. Okay, so here's my graph. And the idea is that how to find a y-intercept on that equation over there, the one that we just came up with. You plug in zeros for x's. That's a y-intercept, right? Plug in zeros for x's. So 0 plus 0 plus 7. So I'm hitting positive 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7. And this thing's like going up in some direction. The reason why I know it's going up, what's the number in front of my x squared? 2. It's positive 2. It's going up. The number in front of the x squared term tells me where it's going. And it makes sense that it's got to be going up because I didn't even hit the x-axis. It can't be going down as we touching it. So now the problem is, I only know this y-intercept. That's it. I need at least a couple more coordinates so I can get a detailed sketch of how this quadratic looks. So that's where, the imaginaries come into play, right? That I know I'm not hitting the x-axis, it's hypothetical, it's imaginary, I'm not going to hit it. But we need to graph this thing still. So we need to complete the square on this problem so that we can actually see where this goal is going to go correctly. Okay, that's our goal today, so to learn how to do this correctly and do it every single time. Okay, so that's what I want to do. So we're going to start with this problem, the problem I give you. We're going to work our way through it. The good thing about this problem is it does have even numbers. It's nice when there's even numbers. I think the problem you guys picked yesterday was odd numbers in it. It's ugly, had fractions and all that. This is going to be nice and neat. Alright, so let's learn how to complete the square here. X squared plus 4x plus 7. Alright, so when you complete the square, you got to have the y on the one side down to 0. 0 is what we use when we're trying to find the x-intercepts. Now that's what I was trying to do here. Trying to find the x-intercepts. But I want to put the y there. So when you complete the square, first step, you move this 7 to the other side. Now what happens when I move it? It becomes negative. Alright, so that's y minus 7. Okay, questions on the first part? Okay, now what I need to do next is there a number in front of my x squared term? Yes. I need to factor it out. It needs to be on the outside of a parenthesis. No, you only take out the leading number. Is a good question. Only the leading number you're taking out, not the x. Because I know some people, like when they factor, don't want to take the x. Put x in the I still want to make this a triangle. So when I take a 2 out, what am I left with in here? X squared plus 2x, right? Because when I take out the 2, I'm dividing both of these by 2. That's how I'm getting to that. Now, why we do this is when you complete the square, I need a trinomial. So that way I know where the middle is, so I can take half of it square and add to both sides. This is the part where it's different, because yesterday we did not have a problem where we had a 2 out front. That's why this is a good problem to kind of work on. So, first step. What's half the middle? 1. Square it. 1. Okay. That's the number we're making up. But now, you have to think about this logically. Is it actually a number 1 sitting there? No, it's actually 2. Because what do I have to do with the parentheses technically? Distribute the 2 back in. And so if I distribute the 2 back into this parentheses, which I'm not going to do that, but if I do, this number is actually the number 2 sitting here. So that's what I have to add to this side. So here's the trick. You take half middle squared, you put it right here, right? Whatever that number is you came up with. You take it times whatever's outside of the parentheses. Whatever's out there. If there's a negative 4 out there, you take it times negative 4. And that's what you put on both sides. So, I have the 2, I have added the 2 to the other side. Okay? Does that make sense to start with? We'll do a couple more of these to get some more practice. It was not just going to be the only one we're going to do. So you can see how the formula works every single time. This side over here actually factors apart, leaving the 2 on the outside. On this side, that's what, a negative 5? This side over here, when I factor this apart, it'll be x and x plus plus. There'll be 2 parentheses, right? And it'll be 1 and 1. How I know what this number is going to be, it's always half the middle. That's just the shortcut. And it's squared. There will be 2 parentheses that are exactly the same because it's plus plus. And now from here, I know where the first dot is. I know where the first dot, because this, we were looking at right here. This is standard form for quadratic. This is standard form. This is how we graph things, right here. And why that's important is because I can read off the vertex, where the start of my parabola is, by just looking at the formula, because I know my x number and I know my y number. What's the number with the x? 1. I need the opposite. Negative 1. What's the number with the y? Negative 5. I want the opposite of it. 5. That's the coordinate where I'm starting. It's always the number with your x and y, but I want the opposites. How I know that? You always set it equal to 0. That's how I always know. So I set this x plus 1 equals 0, solve for it. So the y minus 5 equals 0, and solve for it. So now that I have that, vertex is negative 1, 5, so negative 1, comma 5. That's the vertex, so that's the start of the bowl. So the bowl is going up, right? So if you think about this, if this is the vertex, where's the other dot going to be?
On the other side.
Yeah, negative 2, 7. Because this thing has to be perfectly symmetrical. Like that. You will always have a minimum of 3 dots. You will have some type of intercept. We'll have the vertex. Now, whether we're hitting the x-axis or not, that'll tell you. That's up to the imaginary part. Are we going to have an imaginary number, or is it actually going to work out nice and great? We'll hit some number. Okay. Questions, comments? Let's do another. Let's try another one. So that we can get some more practice with this idea of like completing the square and how to graph it. Okay? I'm going to go through this one pretty quick until we get to the completing the square. Because I think this part, the quadratic stuff, I think you guys pretty much have that down. Know like where it hits the x-axis. But knowing how to complete the square to figure out where the first dot is, and knowing where the actual goal goes, that probably takes a little bit more effort. So let's make up our own problem here. We can pick any numbers we like for A, B, and C. Say it again. B is 8. A is a 3. 7. All right, now I can tell you right now that the quadratic formula is fine and dandy. We'll be able to do that here in a second. The back part, when we do complete the square, we're going to get some ugly numbers. The reason why, the 3s are going to cause some problems. It's going to cause some odd numbers, which is fine. We can deal with it. We can figure out roughly where this thing is going to be. This is good. You need to practice for this. Okay, so let's do the quadratic formula. See where, if at all, we'll like the x-axis. I think we possibly could here. All right, so solving this out. X equals negative 8 plus or minus square root 8 squared minus 4 times A times C and all over 2 times A. So it looks like it's going to be imaginary again. It's the 4 times 3 times 7 turns out to be a really, really big number. We'll see here. Just have a perfect number. All right, so negative 8 plus minus, this number is 64. 4 times 3 is 12. 12 times 7. So it didn't work out, so I can already tell it's imaginary. So, because that would be a negative number. So, am I going to hit the x-axis anywhere? No. So I'm going to stop there. You guys already know from looking at that right now, it's imaginary.
So all I need to know is the leading radical is negative.
Yeah, the radical is. If it's negative, I know I'm not hitting the x-axis. So I know that I'm going to have to complete the square because I need to figure out the first dot anyway. But it's the only way that I can figure out the rest of the dots here. Okay, now where am I going to hit the y-axis at? Questions?
We're doing our homework. Can we stop right there?
Yeah, on the problem that I asked you to graph, if you know it's negative, you can stop there and say it's imaginary roots for the x-axis. You can stop there. I'm totally fine with that. You understand what you're looking for. Okay? All right. But now, where am I hitting the y-axis on this particular created that problem in such a way that it was just 7 perfectly again. Because when you plug in zeros for the x's, we get 7 out. 0, 0, equals 7, so maybe 7 again. Alright, so no big deal. Now what I need to figure out is where the first dot is. Because I know the graph's going up. The number you picked in front of your A was a positive number, so it's definitely going up. If that would have been negative, this thing would be going down. Just to let you know. Okay, so we're going up. We hit a positive 7. Now we got to figure out where and how to complete the square on this thing. And this is where we're going to get some fractions, but it's not a big deal. We can do it. Okay, so what do we got? We got 3x squared plus 8x plus 7. All right, what do we need to do first? The 7 over. So when we do that, we get y minus 7 equals, I'm going to factor out the 3, but I'm going to wait till a little bit here to see that. Okay, we good with that so far? Okay, let's factor out the number 3. So if I factor that out, this is where it gets ugly. So if I factor out the 3, because that was the number in front of my my x squared, I factor out 3. This will be x squared plus 8 over 3x. Because I have to divide everything by the 3, because that's what I'm taking out. Okay, does everyone see how I did that? If I pull the 3 out?
You want to take out the 8 value?
Yeah, the A number. You have to. If it's a 1, no worries. You don't have to equal it. So now that I have that, now what I need to do is I need to complete the square. Half the middle squared. Well, half the middle, it's 8 over 6. How I know that that's half the middle? You put a 2 on the bottom, an extra 2 on the bottom. That's how I cut it in half. When I do that, this actually simplifies the 4 over 3. Right? That's half the middle. Okay, so it's half the middle, and we got to square this. What do I get when I square it?
16 over 9.
16 over 9. That's what I'm going to add here. 16 over 9. Right? But that's not what I'm adding to the other side. It's slightly different. Right? Because that was half the middle squared. It was 16 over 9. But what do I have to take it times? The 3. So I'm taking 16 over 9 times the 3. What that will give you, when you actually do the math here and you simplify, it's 16 over 3. I actually multiply that by the 3 there. Because 16 times 3 divided by 9 is that, and that's what I'm technically adding to this side. So that's how I take the 16 over 9 times the 3 out front. 3 over 1, you simplify diagonally, and this way you get. And that's what I'm magically adding to the other side. Okay, questions on how I did that? What was that?
16 over 3, that just simplifies down, like, multiply over 3 to 16 over 9.
Yeah. Yeah, it just simplifies because the 9 and 3 were diagonal. Okay. Now, on the other side, I need to add that together. Yikes, what is that? I need to get a common denominator. So common denominator there is, what, 3s? So if I multiply 3 to the top, I get 21. And over here, I can factor this. So here's the trick. When I factor this, it'll be x and x, plus and plus, and it's always half the middle. What was half the middle again? 8 over 6, which is 4 over 3. Because you always put 2 in the bottom. That's the middle in half. So that's how I factor it. The other side actually turned out to be, what, a negative 5 over 3? And now I can read off. Now at this point I can read where the starting point is going to be. And my vertex, because that's in standard form now. My vertex, what's the number that's with the x? 1/3, and I need the opposite, so it's negative 1 1/3. Right, that's 4/3. It's 1 like we're repeating. And it's negative because I have the opposite. What's the number with the y? 5/3, which is what? 1 2/3, and I need the positive because I need the opposite of that, so it's 1 2/3. So that's the number with the x, opposite of that, and then the number with the y, the opposite of that. That's just simplifying. If you type it to decimal, you calculate it's fine. 1.6 or 1.3. And graphing this is negative 1.3, negative 1.3 up 1.6, and this is where this thing is going, and that means I have to be over this way, so that was 1 1/3, so I have to go over 1 1/3. So I'll be roughly about right there. And I'm guesstimating roughly where that's at on the graph. So again, how I'm doing that. Once I figure out the middle coordinate, Now I can figure out the spacing for where the coordinates go. So I know what I'm crossing. So it's ugly. You guys picked a pretty evil problem that I picked in that
Can
game.
we have homework problems like that tomorrow, or will they be all like solid numbers?
The numbers that I give you tomorrow, 2 of them will have even numbers, 1 will have an odd. But I don't think the one that has an odd has a number up front. So it'll be a fun. All right. Again, tomorrow's number is really short. Really short compared to what you've seen in the previous one. Okay. Goal today, if you can, get done with the test. Grades will be updated with the test scores tonight because everyone should be done in theory. That's the 2 that we have in here. So you can see your grades tonight.
Jeez, Cassie.
Now a reminder, I'm not here tomorrow. Your sub will be here. They'll pretty much just kind of give you your homework, what you're going to have.
Wait,
What? No idea. I haven't seen the list yet. I haven't seen who they're going to be.
Is Stefan's done sitting?
Yeah, just for now. She'll be back in here probably.